sitting when the evening comes, watching the ships roll in, and then I watch them roll away again. Yeah, I'm sitting on the dock of the bay, watching the tide roll away. Ooh, just sitting on the dock of the bay, wasting time.
Right, folks, hopefully you're not going to waste any time. What a wonderful song that is. Otis Redding, Sitting on the Dock of the Bay. And I've actually, on another note, I've actually been to the place where he sat and actually wrote that song. It's a little village just outside of San Francisco called Sausalito. If you want to have a look on Google Earth what Sausalito looks like, then have a look. Right then. I thought it would quite fit in to introduce this next video, which is all on the process of cliff retreat and how we get erosional landforms and features. So what is it we're going to be learning today? Well, from the last lesson we looked at the 4 different erosion processes, so we've got to use a bit of understanding of what they are to then explain why we get different landforms and features. But also, cliff retreat is actually a process in itself, right? So we're going to sequence that in clear stages. You must have a sketch for this, and then annotate the steps around the kind of sketch. Yeah. Again, we're not Pablo Picasso in geography. We don't need to be. You just need to do a basic diagram. And then also, yeah, how we get erosional features and landforms. Alright. Oops. PC's in battery saver mode, that's good. Always fun doing a live video. I'm not starting it again though, we'll carry on. Right, keywords then. Marine erosion you should be familiar with. Hydraulic action and abrasion, which are our 2 kind of higher energy erosion kind of types of erosion that work, probably the most dominant and most significant in eroding the cliffs and cliff foot. A wave cut notch, wave attack zone, wave cut platform, also known as a shoreline platform, which we'll have a look at in a minute, and then as typical crack cave or stack stump sequence with 2 others thrown in, which are geos and blowholes. Okie dokie. Right then, give it a subheading, cliff retreat, and there is space in your activity booklet on page 10 to actually make a little sketch of this, but you're also going to need room to annotate it as well, which means that it might be better if you do it on a blank piece of paper. It's entirely up to you. Right, yeah, if we just have a look at this graphic, which, yeah, if you pause the video and actually just sketch this and label it nice and big on a sheet of paper, we've got a couple of kind of erosional features shown in this graphic. One is a wave cut platform or a shoreline platform, and the other one is this little indentation in the cliff foot, which is called a wave cut notch. Alright, and I'll show you some photos of these. So we'll start with a shoreline platform. Get rid of that a minute. Right, so you can see where the position of the current cliff is, just here. And once upon a time, if you rewind back in history, that cliff would have extended all the way to this point just here. Yep. So a wave cut platform is evidence of where the cliff was previously. And obviously, over a long period of time, that has been eroded by the sea, and the cliff has retreated backwards. So it would have been here, but it's actually retreated to this position just here. Alright. Key points about a wave cut platform is at high tide, it will be covered, and the waves will actually break on it and then surf inwards. So they tend to be quite polished. Yeah, if you look at this here, it's, you know, it's the erosion processes from the sea have actually sanded it or polished it almost flat. And if you just make a note that these are gently sloped, no more than 4 degrees in angle. So they slope very gently towards the sea, and they'll be never any more than 4 degrees. All right. Another picture. Oops. Clear. Is this one? I think this one's at Flamborough, possibly. Flamborough Head. And again, you see current position of the cliff. We've got caves and arches that you can see where my cursor is. These look like the chalk or limestone cliffs, probably chalk. And this area here is your wave cut platform. No more than 4 degrees, and you can see it's been polished. At low tide, it's exposed, and it'll be covered at high tide. All right, and you can see the high tide mark on the cliff face. It's where the rocks are darker, because obviously the water has maybe been absorbed and saturated into the rock. A wave cut notch is at the cliff foot, and it's basically where differential erosion and the action of the waves have been happening more at the cliff foot. So you can see this notch has been eroded away, and then that material's been removed by the sea. Yeah, so this notch is evidence of differential erosion on the cliff face. All right, this area has been eroded out faster than the part above it. So that's a good picture. Oops. And then we've got another one just here. Look, this is close up, so you can see a notch has been eroded away at the base of the cliff. Right, so you should have an idea of what those two erosional features are. Oh God, what's happening here? Right then. So let's sequence this process then from where the cliff was previously to where it is now. All right, and yeah, I want you to actually put these steps in sequence. So steps 1 through to 9, and I'm going to talk you through it. But you summarise what I'm saying for each step. So step 1 happens just here. All right, and erosion processes of hydraulic action and abrasion erode the cliff foot in what is known as the wave attack zone. It's where the force of the waves are prominent. Yep. This is especially during winter storms and at high tide. So any part of the cliff that's influenced by marine erosion where the waves can have an impact, we call it the wave attack zone. Sounds super jazzy, that, doesn't it? Yeah. When is this the strongest? Obviously, storms, high tide, when the waves are crashing and breaking at the cliff foot. That's step 1. Step 2, the first feature that we get is as wave cut notch. All right. Evidence of differential erosion on the cliff face, because this bit has eroded faster than any of the part above it. So differential erosion. Step 3, the cliff is undercut from below and it's less stable above. So if you think all this weight of the cliff is not being supported by the cliff foot, if you like, because the wave cut notch has eroded away, so it becomes less stable above the wave cut notch. Next, that's step 3, it becomes unstable because it's undercut. Step 4, the cliff collapses. All right. Step 5, the material at the base of the cliff is removed offshore by destructive waves. because the backwash is stronger than the swash. So the cliffs collapse, material and debris at the cliff foot is removed offshore by destructive waves because the backwash is stronger than the swash. And that means that removal is greater than supply. Yep. So when we looked at different kind of systems where cliffs that are dominated by subaerial processes, you tend to find that supply is greater than erosion. In this case, erosion and removal is greater than supply. So it'll take time, but eventually that material will be transported offshore. Next step, we're at step 6, I think I've lost count, here we go. The process repeats itself, alright? So basically the position of the new cliff will now be here, and then it starts again, alright? These lines show the former position of the cliff where it was previously. So we could carry on going, because remember the cliff is going backwards. It's retreating landwards. Alright? What are you left with? Well, you're left with a wave cut platform behind. Yeah. 4 degrees, gently sloped. And the wave cut platform is between the low tide and high tide markers, where the wave influence smooths or polishes it. So again, erosion. Yep, erodes and polishes that wave cut platform almost flat. If you ever want to think as well, why are cliffs often so tall? That is because the former cliff position might have looked something like that, but as the cliff retreats, if the bedrock is increasing in height, then obviously as it retreats the cliffs get taller. Yep, as it retreats. As well as cliffs retreating, then obviously we've got 2 features that form in the previous example, wave cut notch and a wave cut platform. And I think I touched on some of these that I'm about to go through in class. But typical 8-mark exam question, explain how marine erosion processes create erosional features and landforms. Very important to show an understanding of your erosional processes that are at work. So amount of students that will sequence the following stages of erosion perfectly and link it to features and landforms, but don't do the obvious bit and just tell me what the erosion processes are, is quite staggering actually. So yeah, remember you've got to link your processes through to your features and landforms. Alright, so number 1, it might be worth you actually drawing this diagram, or at least sequencing draw the diagram, and then we'll annotate it. Do it nice and big because there is quite a lot to get through in it. This example I'm about to go through will maybe show the difference between a GCSE explanation and a good A-level explanation. Alright then. Step 1. Cracks at the base of the headland become exposed due to hydraulic action. A little definition of what hydraulic action is. So the crack or the fault widens, alright, because of hydraulic action. Step 2. Cracks are further widened by weathering processes such as salt crystallization and wet and dry weathering that affects chalk. 3. Cracks widen and develop into wave-cut notches. Abrasion and hydraulic action deepen the notch to form a cave. 4. Show an understanding of wave refraction. If the sea is and then the waves are breaking from right to left in this example. One question that I always thought of as a student is, well, how can we get caves in the side? And that's because the waves refract and bend around the headland and converge on two sides of the headland, but also on the front as well. Yep, so they bend and refract around the sides. When that happens, destructive waves concentrate their energy on the sides and deepen the cave. Because of wave refraction, the headland's affected on all three sides, and if it so happens that two caves are aligned and you erode through the headland from one side to the other, then we get an arch form. Missed step 6. 6. Vertical joints are exposed by tall breakers associated with caused by destructive waves. You can also bring an understanding of your weathering processes here, which we've not covered yet, and that'll come in a 1 or 2 lessons time just after half term. But yeah, I just thought I'd pop this example in just to show you what a good A-level explanation looks like. Your joints can be weathered from above, so remember, parts of the cliff top that are not in the wave attack zone can still be affected by subaerial processes and mass movements, so you might want to show an understanding of that. 7. This carries on. The arch becomes unstable and collapses under its own weight to form a tall pillar of rock called a stack. 8. The stack is further eroded at its base, creating new wave-cut notches. Rinse and repeat, and then subaerial processes carry on, weakening the stack above the wave attack zone, beyond the influence of waves. 9. The exposed stack, which is now at the front of the headland, in front of the headland, so it's really exposed, collapses to form a stump. Remember, removal by the sea is greater than supply. Materials broken down through attrition, showing an understanding of your third erosion process. Removal's greater than supply, so it's transported away offshore or somewhere else within the bay. So, most of you at GCSE, can remember, rattle this series or sequence off your tongue, which is good. It doesn't change at A level, alright, it's still crack or fault, cave, arch stack stump. And it was drummed into me when I was in year 8 by my super old geography teacher, and it's still true today. It doesn't change. The thing that does change from year 8 or from GCSE is this bit. You can see it's still the same stages, crack, cave, arch stack stump, but the examiner, especially for top band, is going to want to seeing each stage expanded on in detail. Alright, so you can see where the student has drawn attention to erosion processes. They've defined what they are, possibly. In this example, I've also mentioned weathering, abrasion, hydraulic action, but you can see they're showing their understanding of A-level geography, wave refraction, concentrating the destructive wave energy on 3 sides. Subaerial processes. Alright, they've expanded on each stage of the sequence on there. That's what higher level, A-level geography students need to do. Right then, a couple of other erosional features which I'd like to add to my answer if I were a student, especially if you've got any part of your previous 2 sequences in a muddle. then these might help clear things up and help the examiner give you the benefit of the doubt. So geo is an erosional feature or erosional landform, and it's a steep-sided, narrow inlet. All right, different to a bay. This is not a bay, definitely not. And it's caused by differential erosion of a geological weakness, such as typically a fault. Yeah. So once upon a time, there had maybe possibly been a fault running inland from the sea landwards, and in this example just here as well. Yeah. So obviously the marine energy and the marine erosion processes have eroded that faster than the cliff surrounding it. So you end up with a steep-sided inlet. The next one is a blowhole, which if you think of a cave, you've got marine erosion processes making it unstable from below in the wave attack zone, but also you might have subaerial weathering, also making it unstable from above as well. Yep. And if this causes the cave roof to collapse, then you get a blowhole formed, and it can actually create quite spectacular, a bit like a whale in the ocean when they blow water out of the blowhole. Yeah, I think that's where the name probably originates from. But yeah, at high tide and under storms, water's forced into the cave under high pressure, and that pressure's got to go somewhere, so it's released up through the blowhole. Yep, again, it is an erosional feature or erosional landform, and you can see the dog here just having fun. Yeah. Just a couple of points that I want to clear up this year, because maybe I didn't make them quite as clear last year. Cliff retreat, such as this, and these erosional landforms and features, not always, but tend to be when you've got resistant sedimentary rocks, such as chalk, limestone, sandstone, for instance. If we've got a lithology that's really resistant, like igneous rocks, the rate of erosion is so slow, the erosional features don't develop as easily because the lithology is so resistant. On the other hand, if you've got a really softer, weaker lithology, like boulder clay along the Holderness coast, the lithology is not stable enough or resistant enough to actually create taller cliffs. Yeah, it just slumps, and you get more curved profiles. So, resistant sedimentary rocks, sandstone, chalk, limestone, are stable enough to actually create tall erosional landforms like cliffs. Yeah, let's have a look at a few more. Like stacks, for instance. If this was made out of boulder clay, it'd have just been, it's not stable enough to support itself and support its own weight. It'd just slump and be eroded by the sea really quick. Yep. So they won't exist in all honesty. Last little bit I'll finish on, because erosion is basically the removal of material, right? So the sea removes material from the cliff face when it creates a wave cut notch, and then that material again is removed by destructive waves and transported offshore. So you can link erosion to how sediment or material is also transported away from where it's been eroded. So on page 11, I'd just like to draw your attention. Material eroded from cliffs is transported by the sea as sediment. Alright, so your backwash is stronger than your swash. Destructive waves transport it or remove it offshore. So obviously waves are crucial in doing that because they can move sediment up and down the beach. Another thing that can help remove material and sediment are rip currents. Alright, now if you're a surfer or you've ever surfed, then a surfer or a swimmer's worst nightmare is getting caught in a rip current, and they're called RIP for a reason. Really strong currents that go offshore. Yeah, they travel from the foreshore to the near shore and go out to sea. All right, don't get caught in one. For instance, if you do ever find yourself in a rip current, don't try and swim against it, because that's completely pointless. Swim sideways and get out of it. That bit of advice might have saved your life, you never know. Yeah, tides are also important in moving sediment. Tidal currents in estuaries and narrow funneled bays and channels, for instance. And then next lesson, we are going to look at the different transportation processes and how they then lead to depositional landforms. All right. What I want to see, everything nicely subheaded, a diagram for cliff retreat with the 9 stages. Yep. What a geo is, what a blowhole is, and you've got a good example of an in-depth answer to an 8-mark question. You can just see it's packed with keywords. And I'm going to leave you, if you're interested in this song, Otis Redding sitting on the dock of the bay to play us out, folks.
I left my home
I'm in Georgia, headed for the Frisco Bay.
I've had nothing to live for. Look like nothing's gonna come my way. So I'm just gonna sit on the dock of the bay, watching the tide roll away. Sitting on the dock of the bay, wasting time. Look like nothing's gonna change. Everything still remains the same. I can't do what 10 people tell me to do, so I guess I'll remain the same. Listen, sitting here resting my bones, and this loneliness won't leave me alone. Listen, 2,000 miles I roam just to make this dock my home. Now I'm just gonna sit at the dock of a bay, watching the tide